algebra students, welcome back. We are in the last example of section 3.2 and we are going to delve into the whole world of functions. Yes, my friend, this is on the algebra state test and we got to get this one, okay? So hopefully I am very clear and easy to understand. At any point in time you don't understand something, write a question in the margin, remind yourself you need to talk to me about that in class, okay? So let's kind of review just a second. We know that a relation is any set of ordered pairs. All right, now a function, that's what we're talking about today. A function is a special kind of relation. So yeah, we're still working with ordered pairs, but the way your book reads it, it says each domain value pairs exactly with one range value. Most of my students didn't really grasp what that was, and so I wrote this instead, and that's what I want to highlight to you right now. I think this is a little more cut and dry and probably will get you to understanding it quicker. In other words, the x cannot repeat. If you see in the x column that a number is repeated two times or more, this is not a function. Now, if all the x's are different, you got a function. If you see any of those x's repeating, you do not have a function. It is not a function. Okay? And I did want to make sure I underline this very strongly. It doesn't matter. The y's can repeat all day long. Who cares? You could have the same y all day long. The y can repeat. The x's cannot. Okay? So I need to make sure that you understand this. The x's cannot repeat. The y's, they can. Okay? So let's look at example 3, identifying functions. This is part of it. We need to be able to identify when we're dealing with the function and when we are not. First thing they ask us to do is to give the domain and then give the range. So on a table, it's really simple. The domain is always the left column. That's where all your x's are. That's always going to be your domain. So we'll list them. We have 75, 68, and 125. Okay, now your range is always going to be the right column. And so we'll list them, 2 and 3. You don't need to repeat. I know there were 2 2's up there. You don't need to write them twice. If you see the 2, write it one time. Okay? So there's a 2, although it's repeated, and then a 3. Those are the different numbers. You don't have to write repeated numbers. All right, now we've got to tell whether the relation is a function. I want you to circle those 3 numbers. Ask yourself this question. Are they different? Are they all different? Are those 3 numbers different? And if you're going, yes, they are. And they are. 75 is different from 68, which is different from 125. There's 3 different numbers. This is a function. And so that's what you would write. Okay, so we listed the domain. We listed the range, although we didn't write any repeated values, that's okay. And because the x's were all different, none of them repeated, we have a function here. Okay? Now let's flip the page. Now while you're flipping the page, I've got a code word for you. Let's do beach ball. Okay, now look at letter B. We have a mapping. Now in a mapping, you have your x as your left rectangle and the y as your right rectangle. So as you're looking at this, I don't know what's easier for you. You can memorize it a couple of different ways or not memorize it, and I'll show you how to write it out. Now, if you want to just memorize it, that's fine. If you see any of your x values have a double arrow coming from it, that just means that number is being used more than once. If it's got 2 arrows coming from an x value. It doesn't matter if you've got numerous arrows pointing to the y value. Nobody cares about that. The y, it doesn't matter. The x's, if you see a double arrow coming from an x, that means it's not a function. Okay? So what if you're not going to memorize that, or you think you're going to forget it? How could you figure it out? Let's write our ordered pairs. So let's start here with the 7. Okay, so 7, and 7 looks like it matches up with -1, and 7 also matches up with 0. I've got 9. 9 matches up with -7. I've got a 12 that matches up with -1, and I've got a 15 that matches up with 0. Now you could literally take that mapping and turn them back into each individual ordered pair. That's fine, because you may spot it a little more easily if you do that. And this is what you're looking for. Underline all your X's, okay, in the ordered pairs. Underline all the X's in the ordered pairs. Do any of those X's repeat? Yeah, looky there. We have a problem. We have a 7 that repeats. So guess what? This is not a function. And that's my shorthand right here for function, FCTN. But if it's not a function, write not a function. If it is a function, you can just write FCTN, and that'll work for me. Okay? So memorizing it, you could say, oh, I see I've got 2 arrows coming from 7. That means 7's being repeated. And so you could look at it that way, or you can write out your ordered pairs like we did over here. Okay? So hopefully that helps for the mapping. All right, let's look at letter C. I think you're going to like this. It's pretty neat. We're going to give the domain and the range for each relation. This is a little bit harder. This is going to go back to what we did in example 2, so be very patient with me and with yourself. You may need to go ahead and grab 2 colors, because since we're working with a graph, it looks like we're going to have a range of values, okay? So, which means we're going to have to use inequalities. All right, so I'm going to do domain in red. So what we want to do with this circle is we want to focus on the x-axis, and I'm going to mark that in red so you can see it really well. There's the x-axis. That's our domain numbers. And the left edge of that domain is right here, and the right edge is over here. And I've kind of showed those points right there on the x-axis, okay? So we're looking for, you know, where's this circle going through on the x-axis, and it actually goes through 2 points on the x-axis, okay? So this point right here that I first marked on the left, if you notice, here's our origin, so there's 0. This would be -1, -2, -3, and there's -4. So we know that the domain is going to go from -4, and then let's look to the far right side. So we're trying to figure out, well, what number is that, because we don't see it labeled, so we have to deduce it. So here we're back at the origin, right here in the middle. So this would be +1, +2, +3, and +4. Okay, so our numbers range between -4 on the x and +4 on the x. Now, because we're including all the numbers in between, we are going to use inequality symbols. Now, I didn't have to do that in some of these earlier examples. Like for this one in letter B, if I was doing the domain, I wouldn't use inequality symbols. I would just list the numbers I see, 7, 9, 12, 15, okay? And the range is -7, -1, and 0. When you deal with graphs where you're finding the outer barrier edges to the graph and it's all the numbers in between, you're going to need to use inequality symbols, okay? So hopefully that makes a lot of sense. And if it doesn't, I'm so sorry. We'll talk about it in class tomorrow, okay? So here we go. We're going to start with our smaller number, -4. And we're trying to get all the numbers between -4 and +4, including -4 and +4. So we're going to use less than or equal to. Remember, what variable is associated with domain? Right, x. Okay, and then we'll do less than or equal to +4. So there's our little tight range of numbers that the circle, all the points on the circle lie between, their x's lie between -4 and +4. Okay, hopefully I showed you those outer barriers there. Now I'm going to switch colors because it's time for the range. Okay, so I'm going to absolutely do range in blue this time. Range is your y-axis. So this time we want to find the top edge and the bottom edge where it goes through. Here's our y-axis. I'll kind of highlight that in blue, make it stand out to you a little bit more. And then here are our 2 points, here and here. Our circle, that's where our circle goes through on the y-axis. So that's our barrier, that's our edge, okay? Now the lower number is going to be down here at the bottom. See where my pencil tip is? So I'm going to count down, here's 0, and I'm going to count down negatively. So I've got -1, -2, -3, -4. Okay? And then my top point, that's the positive number. So numbers above 0, positive, numbers below 0, negative. So we'll start here at 0. We've got 1, 2, 3, 4. So my numbers also, just like the x-axis, also on the y-axis have the exact same range of numbers. It's just on the y-axis. That's what circles do. If it's like an oval, there'll be different numbers for the x and y. But because it's a circle, I'm not that surprised that the numbers turned out that way. So we're going to start with our lower number. Use your less than or equal to symbol. Now wait a second, we're doing range. So what variable do we associate with range? That's right, the y. And then we'll finish it up. Okay, looks good? I hope it does. I hope it's getting a little easier for you. All right, now I'm going to switch colors again. I'm going to do this really cool green color because now we got to determine whether or not it's a function. Okay, and this is what I want you to focus in on, what I wrote here. We're going to use something called the vertical line test to determine whether or not it's a function. You use the vertical line test on graphs, not on mappings, not on tables, not with ordered pairs. You do the vertical line test on graphs, okay? So a vertical line is the line just like the y-axis that goes north-south. That's a vertical line. So I'm going to draw a vertical line, a couple of them, through this graph, okay? All through it. And what you're looking for on these vertical lines is whether or not it passes on that circle at exactly 1 point or more than 1 point on that vertical line. So let's take this first vertical line that's here, okay? The first one I drew on the left side, okay? Let's take this one. All right, notice that it crosses here and here. Let's go to the one next to it. So this line right here, to the right of it, it crosses here and here. You see there's 2 points on that vertical line. My vertical line is going across 2 points on the circle, here and here. Focus on the circle, not on the grid. Focus on the circle. The grid's got all kinds of lines. You almost have to ignore them, okay? So if you need to, if the grid's really bothering you, let's draw a tiny little circle like right here. And let's do a couple of vertical lines through it, okay? Do you see where it's crisscrossing through 2 points? Each of those 3 vertical lines that I drew go through more than 1 point. If that happens, if it goes through 2 points or more than 1 point, then this is not a function. It has to go through exactly and only 1 point in order for it to work, for it to be a function. Okay? Now I'm sure I just completely confused the mess out of you. So let's flip to the next page, and I want to do the same thing with the parabola on the left. Okay? So the parabola has kind of an arc shape. And let's switch back to another color. Let's do the domain, okay? Remember, the domain is anything on the x-axis. Now, I don't have a beginning and I don't have an end on the x, because a parabola is going to continue to get wider as it goes down, okay? It's going to get wider and wider and wider and wider. There's no beginning or end on the x-axis. So when you see this situation, you would go, oh, this is all real numbers. Every x is being used. All real numbers. Every x is being used. There's no starting place and there's no ending place. Okay? Not for the domain. Now the range, there's a little bit of a limitation. Okay? Now let's see if we can find that on the graph, what the limitation is. Okay, notice this point right here on the y-axis. Let me kind of pinpoint the y-axis here. Okay, you see your y-axis, and here's the topmost point. There is no graph of that parabola above this point right here. Okay, so all your y's are at 0 or below. So how do you write an inequality that shows 0 or below? Well, let's do an inequality. We're dealing with range, so we're going to do y is less than or equal to, and then figure out at what number is this point on the y-axis. Now it is labeled, so hopefully you see 0. Okay? Now I'm going to switch to another color, because to determine whether or not it's a function, you need to do the vertical line test. So I'm going to put a vertical line just a couple of places through this, okay? And does it pass through exactly and only one point? And the answer is yes. It's not passing through 2 points. It's passing through 1 point. So this is a function. So here's an example of a function. Now I will tell you, all circles are never going to be a function. All circles are not functions. And all parabolas that open either up or down are functions. So if you just want to memorize that, that's fine too. But the vertical line test works beautifully. That's the best way to tell from a graph. All right, now I'm going to leave this as extra credit. So I'm going to put back into, let's do this. We've got extra credit, and I'm going to let you do the domain. And the domain, just focus on the x-axis. So I'll kind of highlight that in red. There's the x-axis, and notice you have a barrier here. The parabola doesn't pass this point on the x-axis, so that's going to be an inequality. Okay? Now I'm going to change colors, and then the range, notice that the range is your y-axis, and it looks like since it's opening up sideways, this is kind of a sideways parabola. You'll see more of these in Algebra 2. We're not really going to do too many of these except for just the purpose of identifying domain and range and determining whether it's a function. And so the range doesn't really look like you have a beginning or an end. So what would you write for that if there's no real beginning and there's no real end? And then the function, you need to put a couple of vertical lines through your graph, through the parabola. Okay, now if the grid's messing you up, then let's just draw the parabola here off to the side and do a couple of them, right here. Remember, if it passes the vertical line test, your vertical line passes through only 1 point on your graph. If it passes through 2, it is not a function. Okay, so you're trying to determine whether or not it's a function or not a function. Okay, all right, now on the next page, yes, I've got a couple of more. What I want you to do is identify whether this is you're going to tell me underneath function or not a function. And so you're going to practice a graph a relation, and a mapping. Okay, so that's actually 3 possible, maybe even more. I haven't decided how many points. The other graph is kind of hard. So let's go back to this page and let's just go ahead and say +1 for the domain, +1 for the range, because it's possible that you could miss one and not the other one. And then we'll do a +1 for the identification of whether or not it's a function. Okay, fair enough. So that's 5 possible points for this example. Good luck with it. And if you didn't understand, let's rewind, listen again, and then try again. All right, bring your questions to class if you have any.